All right, it is
Okay.
working. Okay.
Cool.
All right. I think it's now streaming. Okay, we'll see what this does. All right, hey everybody, welcome to the Nirmata office hours for Kyverno. For those that may be seeing this live or watching the recording, this is an informal office hours that the maintainers at Nirmata, who are the creators of Kyverno, hold to answer your questions, talk shop about Kyverno, and also we bring an agenda to you each time so that you can watch this and we cover a specific topic. So all questions are welcome, all inputs welcome. For those that are joining us as participants on the meeting, welcome, and you're open to introduce yourselves if you'd like to. Otherwise, we will start talking about PSP migration. So PSP migration. So as folks probably know, PSP's pod security policies were deprecated in Kubernetes 1. I think it was 21 was the official beginning of the deprecation. And they are removed as of 1.25. So deprecation, not the same thing as removal. Removal as in they are gone in 125. You cannot use them. So we get this question a lot from folks in the community, is that we know that they're going away. We're still using them. We've got to find an alternative. Number one, what are the viable alternatives that are out there? And if, Kyverno, which is a more than capable replacement, as we'll talk about today, is the thing that you select, how do I go about migrating to get off of PSPs and onto Kyverno in a way that is non-disruptive to my existing operations? So first, I thought I'd just cover what the options that are out there are. And let me share my screen here. And so these are your real options. And a lot of this comes from the Kubernetes documentation. So we'll talk about the current state the prior to removal state of PSPs, the internal replacement, which is PSA or pod security admission, and then we'll talk about how both of those stack up against Kyverno. So starting with PSPs, as the name implies, PSPs are pods only. It's designed only for pods, and that's great. But as probably everybody knows who's operating a Kubernetes environment, pods aren't the only concern that you have. Even when it comes to security, there are many other things and dimensions to Kubernetes that need security than just pods. So PSPs, pods only. Pod security admission, the replacement for PSPs that also only handles pods. So pod security admission, like pod security policy, is an internal admission controller. It's not an external or a dynamic admission controller. Pod security admission only handles pods. Kyverno handles anything that you want to. Obviously, pods, since we're here talking about pod security policy and replacements and migrations, Kyverno will do anything. It's not just focused around pods. You can validate config maps, ingresses, even your own custom resources. Doesn't matter what it is, Kyverno can handle that from a validation perspective. So just keep in mind, when you're looking for a replacement for pod security policy, if you're just looking for something to handle pods, that may be fine, but chances are you probably have other needs right now. And if you don't, you probably will very soon. So do you want to use multiple tools, or do you want to use one tool? So options are really up to you. So that's the first item there. Second option, or the second line item here, you have limited options with PSPs. For those that are using PSPs, no, you only have, I think it's something around 16 or so fields that are in PSPs, and that's what you get. So it doesn't cover everything that's in the pod spec. It's just the things that impact most of the security aspects of a pod. So you have fairly limited options. In pod security admission, things have evolved a little bit. What they've done is they've broken down into buckets, kind of, if you will, the options that are available in PSPs, and they've separated them into what are called profiles. And there are basically two profiles in pod security admission, which pod security admission implements pod security standards. And so that's actually where the profiles are. There's the baseline, which has the most basic security fundamentals for a pod spec. So it groups about, I think it's about 8 or something in the baseline profile. And then there's a restricted profile, which goes even further to do more lockdown on pods. I think there's another like 6 or 8 or something like that in restricted. So since pod security admission implements pod security standards, you have two options in pod security admission. And both of those options are those profiles that I just mentioned for pod security standards. You can implement baseline profile, or you can implement restricted profile. And restricted builds on top of baseline. So if you implement baseline, you get, let's say 8. I can't remember what the exact number of controls are. If you implement restricted, you still get baseline. You're just adding the restricted on top of that. So those are your options in pod security admission. It's only pod security standards, and you only have two options as far as what the levels that you can implement. So by the way, that asterisk there, that means that there are gaps. If you go and look at your pod security policies, there are some fields that PSA does not handle. So for example, there's a field in pod security policy that's read-only root file system, which is super useful, and you really should be trying as much as possible. And maybe you are enforcing that pods require a read-only root file system. That's a great practice to adhere to, because if you're running a container with a read-only root file system, no changes can occur. Even if somehow a breach were to happen, they're very limited as far as what they can do. They can't manipulate the file system. That option's not codified in pod security standards. So if it's not in pod security standards, pod security admission can't give you a control for it. So that option's off the table. Also, runtime class. Runtime class is a really useful feature that's in the pod spec that allows you to set a type of a class of a pod runtime or container runtime to use, which you can then reference in the pod spec. That also is not covered under PSS, which therefore means it's not covered under PSA. And there are some other deprecated options that are in PSS as well that I didn't mention those, but those are the two options that are going to be gaps between PSP and PSA today that are still in the spec and that are still in use. So keep those in mind. Even if you do decide to check out PSA, when you go looking for those options, they're not there. So you're not going to have them. Kyverno, you can enforce whatever you want from whatever field that you want. Doesn't matter what it is. So if you want to get all the PSS standards, in fact, we actually build those for you as policies. They're already pre-built. And some of the other maintainers are going to talk about and show how simple that looks like with Kyverno. It's super simple and actually builds on PSA, so it's super cool. But you can enforce whatever fields that you want. That means that you can get PSS in addition to read-only root file system, in addition to runtime class, and other fields that you want. So there's really no limitations with Kyverno. So that's the second thing to be aware of. So before you look for a viable alternative, check your PSPs. If you're using read-only root file system and runtime class, you'll need to figure out what you're going to do. Again, one or multiple approaches. You'll probably need coverage for it, because it's unlikely that you're going to say, nah, we don't want to do that anymore. We're just going to stop requiring that pods have, read-only root file system. You want to really maintain that if you can. PSPs, as probably everybody knows, especially that are using them, it requires RBAC modifications. So a PSP does nothing unless you enable a principal to use it, which means that if you haven't done it in the right order, this is actually a breaking change. And I remember years ago, actually, when PSPs were all there was, I had to implement this in a customer environment. I actually caused a cluster outage because I didn't do it in the right order. I implemented the PSPs, but I didn't implement the bindings. And so when we flipped it on, it took out a large chunk of the cluster. Now, if you're running PSPs already, you already got that under control. But to use PSPs, it all requires RBAC. Oh, actually, I forgot one thing on so going back to the limited options thing on PSPs. So PSA, pod security admission, there's no mutation capability in that. So in pod security policy, you have the ability to set defaults. There are a lot of fields that allow you to set defaults, which performs a mutation on pods. So if you set run as, I think it's default run as user is one of them, there's several others. If you don't specify run as user, pod security policy will inject that as a value. Pod security admission does none of that. There's no mutation whatsoever. So keep that in mind when you're looking for a PSP replacement. If you're using those mutation features, you're not going to have them in PSA. Kyverno, again, mutates anything in any way that you want to. So going back to the RBAC mods thing, so that's PSP that folks that are using PSP already know. Everything has to go through RBAC in order for it to be authorized and consumed. Pod security admission, however, doesn't require RBAC, at least not in that way. You really have two options. You can write a cluster-wide file, or you can label a namespace. So it's more flexible in that it's not bound to RBAC. So that's PSA. And then Kyverno is similar to PSA, but it's even more flexible still, doesn't require any RBAC to consume. As soon as you have a policy that's instantiated in your cluster, whatever you match on, Kyverno will see and filter that down into its policy engine. Now, if you want, and we can talk about this later in the actual ways to go about the migration, one of the ways that you can migrate from PSPs to Kyverno is you can have Kyverno initially do the same types of thing, as in matching on those types of pods, but also on a service account called, foo or whatever the case is. So you can still get that same behavior as a part of the migration flow with Kyverno. And then when you're comfortable that everything is working like it is and you've removed the PSP analog, you can open that up even wider if you want with Kyverno. It's just a simple match. There's no RBAC modifications that you have to do. So that's PSP to PSA to Kyverno when it comes to how you actually consume it. RBAC mods on PSPs, either cluster-wide file, which is not an API resource, or a namespace labeling for PSA. Kyverno, you just have a policy that exists, and whatever you want to match on in any way will be caught by the policy. And folks are on the call, feel free to jump in if I'm not doing justice to something, or if I'm forgetting something, just hop in and add your 2 cents on that. So further on the PSP note, so you're limited because it uses RBAC mods to users, groups, and service accounts. Now there's some flexibility that you have there, like you can bind to service accounts in a specific namespace, but you're still limited because it has to be run through RBAC. It has to be associated with a user, a group, a service account, or some combination thereof. So that typically means what we see is that you have this proliferation of PSPs that are needed because you have this snowflake combination of maybe you're consuming the same PSPs, or there might be slight variations, but there's a very specific binding order that you have to users and groups and service accounts. So it can get really messy over a period of time to the tune of potentially hundreds of those combinations. And it's really tricky to try and keep track of all that, because if you make a change in one thing, where are all the bound principles that are going to be impacted by that? It's really difficult to understand what that impact is going to be. Pod security admission, like I mentioned, the scopes there, you have cluster scope and you also have namespace scope. So in pod security admission, again, since it's an internal controller, you can apply pod security admission to the entire cluster by default, but the thing is, it requires that you write what's called an admission configuration file, which is known only to the control plane. So it's not an in-cluster Kubernetes resource. You have to create a custom file. You have to pass it as a flag to the API server, which means if you haven't done this, especially if you're on a cloud provider, that's not just a disruptive change, that's a destructive change. Like, you have to destroy your cluster to do that. And most cloud providers don't even allow you to do that anyhow. So you just have the namespace option. But anyhow, the cluster option, you have to maintain a file that all the control plane nodes have to have, or the namespace option, that's the lowest level of granularity. So you can just apply it to that. And you have to label a namespace to do that. So it's an all or nothing thing. You're either going to get all a cluster, and you can do opt in or out per namespace, or if you're going to go with the namespace level, that's what you get. From Kyverno's perspective, you can associate with anything that you want. You can associate with the exact same things that PSP wants. You can associate with the entire cluster. Kyverno has a cluster policy that allows you to just write that and have it be enforced across the entire cluster. You can have it enforced in the namespace. You can have, there's all sorts of things. Not going to go over all of the possibilities, but if you can think it up, and if it's a construct within Kubernetes, Kyverno can use that as a filter to apply policy to it. So you're much more flexible as far as the associations that you have. No support for pod controllers. So those of you that are using PSPs, you probably know how much of a bummer this is. Somebody creates a deployment, the deployment creates a replica set. You got the thumbs up from the API server, yep, that was created, everything's good, but there are no pods running. So you go and do a describe on the replica set and you see, oh, pods were blocked because pod security policy denied them. Well, that's not really a good experience, is it? I mean, letting people create things and then, but it actually doesn't work, not really the greatest thing. So anyhow, pod security policy, that's what you got. There's no support for pod controllers. All it's going to do is block pods. Pod security admission, almost the same type of story. The only exception is if you're in audit mode for pod security admission, which is you're going to let something through, but it'll at least tell you about it. It will tell you that the pod controllers technically fail one of the profiles, but if you're in enforce mode, it won't. So if you're in enforce mode, you get the same behavior as PSP, which is it's going to block pods, but it's going to allow your pod controllers to go through. Still a pretty big bummer right there. Kyverno, we have what's called rule auto generation. So if you write a rule for a pod, there's nothing else that you need to do. Kyverno is going to, behind the scenes, automatically translate that and apply it to any of the major Kubernetes pod controllers that are out there. So if you have a pod, if you have a policy, let's say, do not run as privileged, and you say match on pod only, I don't want any of my pods to run as privileged. All you got to do is create that in the cluster. Kyverno handles making sure that that gets enforced equally for pod controllers. So if that's in enforce mode, you create that same deployment that gets allowed by pod security policy or PSA. Kyverno is going to block that and tell you, no, the deployment shall not pass. It's because there's a policy that's in place. And so you never get to the point where deployments allowed, replica sets are allowed, but pods are blocked. Kyverno will block it at the source and let you know immediately. And of course, if you don't want that behavior, in all of the things that we're talking about, you can get exact same behavior that you want in PSPs. If you really, really want that experience and you don't want to change that flow, you can do the same thing with Kyverno, but by default, Kyverno will give you those auto-gen rules. But it's a matter of a simple annotation to flick that off if you just want to say, no, I only want to block pods, which Kyverno, by the way, will do anyhow. So it doesn't matter whether you get auto-gen or not, it's still going to block just pods. But if you want to get that behavior, you can certainly do that. It's really just an annotation. No auditing. So in PSPs, there's no auditability. You're either blocking something, you're not blocking it. There's not a way to see, well, you know, this pertains to a PSP, but we want to know about it. You're not going to get that. It's just, it's an all or nothing thing. You're going to block it or you're not going to block it. Pod security admission does improve on this. So by assigning those labels that I mentioned, which is how, by and large, pod security admission is operated, it will show audit messages if a pod violates a profile that has been activated in pod security admission. But here's the thing, all of that information is only available in the Kubernetes audit log, which means that if you haven't created your cluster with logging available and you're either sending to a backend or to a web backend or a file or whatever, That's now a disruptive change to enable, because you got to go in and you have to pass a flag to the API server. It's got to restart. And also all of that stuff gets dumped into the same audit log. So unless you're using a cloud provider and you're also doing some really good filtering on the audit logging, which by the way is going to cost you some money, because that log is for large clusters, that log's going to be churning out some data. It's all going to be dumped in there. And so you have to figure out how to parse it to get all of that stuff out. Doesn't mean it's not accessible. It is accessible, but it's very cumbersome to try and get that information, so that you can just simply ask the question, hey, which pods exist right now that are doing bad things that we need to go tap somebody on the shoulder and say, hey, you know, you really need to remediate these things because we're going to enable this in enforce mode later. It's a lot more cumbersome to do that in PSA, but nevertheless, you can still do it. When it comes to Kyverno, Kyverno has this nifty feature called policy reports. Policy reports are just another standard Kubernetes resource, which, by the way, is an open standard. It's not a Kyverno esoteric standard. It's created by the policy working group. And Jim here, one of the co-creators, is on the policy working group. They created this as an open standard, which any tool can use. And there are many tools that actually do use the policy report format. Kyverno generates those automatically for you inside of the cluster, which means you don't have to go fish through an audit log to see all of that stuff. You can see it in the cluster as another Kubernetes resource. And that's super great, because the cool thing that allows is you can now separate people who are able to write and see policy and those who are able to see policy reports. And also another thing that enables is you can use all sorts of tools, maybe tools that you're already using, including open source tools like Policy Reporter and Nirmata Policy Manager as a SaaS, to go and look at those policy reports, scrape them, alert you about them, send you in an email, like all sorts of things you can do with those. And none of that involves digging through an audit log. It's all in cluster with policy reports. You can retrieve them with kube control. Very simple to look through and parse. So that's how getting feedback for pods that are in violation stacks up. PSP to PSA to Kyverno. No message customization. Probably not the hugest deal, but you get what you get as far as a message is concerned with PSPs. You also get what you get with PSA. The problem that we typically hear with this is, well, you know, in a large environment, we've got a lot of different teams using this. To whom does somebody need to go and speak to understand either what to do, although that's made pretty simple with Kyverno, or who do we need to talk to get more information about this? With Kyverno, you can put whatever you want in a message field and have an email or a name or an office number or a phone number or whatever you want to wherever, whatever you want information surfaced when it's in enforce mode. So if something gets blocked, you can customize the message that gets returned into whatever you want. So it's a very nice thing to have, especially in larger organizations and clusters, so that you don't just slam the door shut on someone with a default message and say, pod denied, this field is set. Like, some people don't know what to do. So that can be super helpful. Here's one of the biggest ones: no exclusions. No exclusions in PSP or PSA. So in other words, whatever you define in your policy or whatever you've enabled in PSA, that's it. There's no exclusions that you get on top of that. You can only include. And once you've included, that's it. So PSA, it's even less flexible, because remember what I was saying at the outset, PSA is broken down into pod security standards, PSS profiles. So when you enable a profile contains a whole list of controls. Once you enable that profile, you cannot exclude for anything that's in that profile. You're getting all of that profile or you're getting none of it. So no exclusions in PSPs or PSAs. The problem that this ends up having is you're probably using tools like service mesh or monitoring tools. Sometimes those tools legitimately need access to certain capabilities that are going to be forbidden by pod security policies or pod security admission. But you need those tools to operate your cluster, because obviously Kubernetes doesn't give you everything. you're out of luck when it comes to those. You're going to have to turn off. You're going to have to either decide, I'm going to turn off this thing and across the namespace, or I'm going to look for something that gives me exclusions. Kyverno, fully flexible exclusions. You can exclude down to, I mean, as far down as you want to. So it's very easy to do things like in a pod, the Istio init container can have additional capabilities, for example, because that's one of the ones that we see, but all other containers cannot have any of those capabilities. So you let those pods pass, but you're still enforcing the security profiles that you want on the fields that you want, but only at the granularity that you need. So Kyverno can give you that in a very flexible fashion, basically any way that you can slice and dice a pod spec, whether it's image name. And that's one of the cool things about our integration with pod security admission that I think Shuting may show you, that we have a very simple way to do that on a per image basis without having to even do any more complex policy lingo that Kyverno does allow you to perform. And lastly here, this kind of goes without saying, but just calling out, PSP is integrated, pod security admission is integrated, they're inline features to the API server. Kyverno is going to be an external solution. So there are trade-offs when it comes to these types of things. Having an external solution means that you can do all sorts of things in that solution, but anyhow, that's a decent breakdown of the comparison options between PSP, pod security admission, and also Kyverno. Any questions or follow-ups on that? Anything that I left out? Okay. Well, with that said, why don't I give it over to Shuting, who's actually going to show what Kyverno can do internally when it comes to enforcing pod security, but by using the same upstream libraries that the pod security admission features, albeit in a much more flexible and user-friendly way. So Shuting, why don't you take it away?
Yep. Thank you, Chip. I think you're setting a very detailed context for this PS demo today. Thanks for that. Okay, in this section, I'm going to show you the the examples of how to enforce pod security standards using Kyverno pod security policies. So as Chip already explained, the pod security admission is in the entry solution to enforce the pod security standards. It's became stable in Kubernetes 1.25, and it's very easy to enable when it comes to the namespace base. Of course, if you want to enforce across the entire cluster, you have to do some cluster configuration during the initialization. But if you only want this behavior for specific namespaces, it's very easy. Just add the label to the namespace, and you're able to configure the mode and the restrict levels. And go back to the pod security validate type of rule in Kyverno. Today, I'm going to show you two examples. One is to use the Kyverno pod security rule to enforce the privilege escalation, and another is to enforce the capabilities, all at restricted level. So let me switch to the examples I have. So first of all, I want to explain what does the pod security rule looks like in Kyverno validate. So I did a kubectl explain on the CPOL, that's cluster policy, spec rules validate. And under this pod security attributes, I have this exclude block. And if you take a look at this field, I have the control name specified. The images allow you to select the certain images that you want to do the exclusion. And this is the new field called restricted field that allows you to do the exemption at the specific given path and then the values you want to exempt. So the last two attributes are added to the advanced support of pod security admission, pod security in Kyverno Validated. So this is what the rule looks like. And here is an policy. I have a cluster policy here. And again, if you look at the validated pod security, I have the level set to restricted. That means I want Kyverno to enforce the PSS at the restricted level with the latest version. And then I want to do the exclusion. Here I'm selecting the control by its name, privilege escalation, and I'm selecting on the image, Nginx with whatever the tags or the hash you specified in your workloads or pods. And then I have this control restricted at this field for the init container. I want the allow privilege escalation to be set to true. And if I have any pods or workloads having this setting, I want Kyverno to exempt this check, but apply all other restricted PSS checks. So yeah, this is pretty straightforward. And let's look at the pod example here. I'm having a pod with two containers. One is the init container with the Nginx image. I have the security context, allow privilege escalation set to true, and then the same for the container. So same setting on this attribute. So by default, if I have PSA, the Kubernetes pod security admission enabled at a certain namespace, then when I try to create that pod, the PSA will reject this pod. But with the Kyverno policy, I'm still applying all the PSS checks, restricted level, but I'm doing the exemption that, my pod running the security context with this setting should be allowed. Okay, so let's pull up the terminal. And actually I have two namespace created. One is the PSA, the Kubernetes pod security admission enforced namespace, which is called PSA here. If I do show labels, get namespace. If you look at this namespace PSA, I have pod security set to enforce mode, and I wanted to apply all the restricted checks. And another namespace I got is the Kyverno PSA, where my policy is going to enforce all the workloads and pods in this namespace. Okay, so let's apply the policy first. Do a kubectl create, and then -f privilege policy. Now I have the policy in place. And let's try to apply this pod into the PSA namespace first. The expect behavior is that the Kubernetes should reject the pod creation. So let's do kubectl create privilege pod and then -n namespace. As you can see, Kubernetes says that, okay, both of my containers must set the allow privilege escalation to false, because that's the only allowed value at the restricted level check. And then I'm going to apply this pod into another Kyverno enforced PSA namespace. Okay, you can see it still get blocked. This is because my rule is specifically exempt at for the init container, not the container. So as you can see, there's still another value saying that your spec.container 0, that's our first container, is still violating this rule. So all you have to do is to, configure your Kyverno policy, remove this restricted field, then the Kyverno policy will exempt this privilege escalation check at all fields specified in pod security standards. As you can see, it enforces at 3 different fields for container, init container, and infirmary container, right? So if I remove that, then Kyverno is gonna exempt for all types of containers. So let's create that pod again. Sorry, I have to apply that policy first. It's privilege escalation policy. Okay, it's configured. And then if I try to create that pod again in the Kyverno PSA namespace, now this time I'm able to get the pod created with both of the violations, for the PSS. So this is the first example I want to show you. You can do the customization at restricted field, then Kyverno will do the proper corresponding exemptions for you. Okay, let me pause here and see if we get any questions and comments. Okay, if we don't have any questions, let me split it. So the next example I have is to, have another pod security type of validate rule in Kyverno that enforce the capabilities check. And now this time I want to do some customization on the values, right? So if you look at the pod security standards, the restricted capabilities check, it actually has two checks here applied on different paths like security contacts capabilities.drop. It has the allowed value that any value include all, and at the capabilities.add, these are the allowed values, right? So if you go back to the Kyverno policy, I'm trying to make an exemption at containers level. And then this is the value I want to exclude, right? So that means in my pods workloads, if I have the capabilities.add security context set for my container, and the value is set to kill, then the pod should be created. Otherwise, it should block for me. So this is my pod on the right side. I'm running a busybox image, specifying that I have this capabilities.add set to kill. So this will be exempted by Kyverno. And if you have this set UID uncommented, then the pod should be rejected because that value is not excluded in this Kyverno pod security rule. Right, so let's apply the policy first. Let's do a kubectl create. And then this is capabilities, policies. Okay, I have the policy in place, exempt capabilities. And then let's first uncomment this set UID. The expectation is the pod should be rejected because, obviously it's violating the settings. So let's apply the pod capabilities, pod add kill, and then Kyverno PSA. Right, so this time you're saying it's restricting the pod creation because the capabilities add cannot have the set UID. And if you comment it out, then the pod should, pod creation is allowed. And again, just to, compare with PSA, if you change the namespace, this pod creation will be rejected because, you have invalid value set there. And similarly, with a single validated pod security rule, you can configure multiple exclusions for different control or at different restrict path or with different values. Let's say, for example, if you have another pod, you want to exempt the pod to drop the KO capability, then here I'm specifying the second control exemption, selecting the busybox, and I'm specifying this restricted field at container level. Then I'm exempting the drop capabilities here. So if I update the policy, say update and then policy, the expectation is that this pod should be able to create with Kyverno. policy in place. So the policy is not, oh, this is not privileged escalation. This is capability policy. Okay, now my policy got updated, and if we try to create that pod again, another pod, drop kill and Kyverno dash ESA, this is the pod creation is allowed. And just to compare it with PSA, because PSA requires the auth to be specified for your drop capabilities, obviously the creation won't pass. Okay, that's two examples I have for today. And Liang here is on the line with us together. He's the mentee of this pod security admission integration under the CNCF Linux CNCF LFX mentorship project. So we're currently trying to make the changes to the upstream repo, then integrate whatever the changes to the downstream Kyverno repo. So hopefully this change will be released by the next Kubernetes version, and then it should be available in Kyverno.
Yeah, so shifting just to reiterate for folks that are interested in this and to separate. So the pod security sub rule that we call it in Kyverno is available today. It's been there since 1.8. There have been some enhancements lately, but this restricted fields that Shuting is showing is not currently covered in the release, where this is the subject of the mentorship. We're awaiting some changes in upstream Kubernetes to be pulled in before we can pull this in and incorporate it in a release. So everything else other than that restricted fields is available in Kyverno today, and we're hoping to see that in a future release soon.
Yep,
So
and about
targeting 1.11 for these new restricted fields.
If it
Yeah,
gets pulled in time, yeah.
we're relying on Kubernetes to have this in place.
Okay.
Yep, that's it for the pod security rule.
All right. So yeah, what I can quickly show is, again, another way, like Chip mentioned, you can configure pod security in policies or implementations in Kyverno itself, right? So what Shooting was showing was the pod security admission sub rule, which implements the two profiles, restricted and baseline. But in many cases, you might want more flexibility, and Kyverno does have full support for every control listed in the pod security standard. So this is, you're just looking at our policy library. You can install these as individual policies, right? So, and each one of these will check the right control. It refers upstream into whichever standard that control is defined in, and then has the specific Kyverno checks. So in this case, it would be Kyverno checking this, not the upstream library, which would be used in the implementation that Shooting showed. So in my cluster here, right now, I just have the latest Kyverno running, but I don't have any cluster policies. So just to install these, what I'm going to do is I'm going to run customize, which pulls down all these pod security policies listed in the Kyverno repo, right? So this is our sample policy repo, and it's just going to do these in enforce mode through customize, and then apply them into my cluster. So at this point, like going from, again, 0 policies to, kind of pod security implemented is very simple, very trivial, and we maintain this for different versions of Kubernetes releases. This gets tested, so it's fairly easy to use, right? So now if I try to, let's say, run, a pod, I'm just trying to run Nginx, and I'll just do a dry run. As expected, I see various failures, right? So it's telling me the pod needs to kind of drop all capabilities. Privilege escalation has to be turned off explicitly, as well as, things like seccomp and run as non-root need to be set, right? So this is super simple. Another way And by the way, you can mix and match, right? So you can have pod security admission applied across all of your namespaces, but then have specific rules which apply to certain workloads if you so wish, right? And you can put those in the same policy, and through Kyverno feature of being able to match the first rule that applies, it will only match the specific rule and not apply the catch-all into your workload if you want. So a lot of flexibility there. But now, what if again we're back in the situation where we set these policies, we're using the library, but we want some workloads to be excluded, right? So for that, Kyverno also has a feature for policy exceptions, and this was introduced, I believe, in 1.9 as well. And what this does is it allows you to set exceptions or exclude certain workloads outside of the policy definition itself, right? Because in this case, remember, I'm using just the upstream library. I don't want to go change these policies, but I want to exclude certain workloads just because maybe they need more time to get the right security controls in place, or for other reasons, it's a third-party tool and I can't change it or can't update the image, things like that, right? So to do that, Kyverno has this feature of policy exceptions. This is another custom resource which was introduced with 1.9. It is right now in V2 alpha. We will be moving it into kind of a more stable release because it's fairly well defined. There are a few additions and other things we will add to this, but the existing declarations are not likely to change. And here what you see is, in this policy, what I just did is all of these which were flagged for this particular image that I'm running, I want to define some exceptions, right? So I want to say for this policy and any rule, I've just wildcarded the rules. You could be very specific with these names if you wish, but here we're just saying for these policies, I want to exclude, but I only want to exclude it for Nginx in this test namespace, right? So I can be fairly specific, and this mimics the Kyverno match and exclude block, so I can put anything that I can in the match block over here as well. So you can get fairly granular. Doesn't have the same level of granularity as what Shooting just showed with the controls yet, but as that feature stabilizes, we will likely add it into the exception declaration itself. So let's see how this works, right? So now, as you saw, if I try to, let's say I have this test namespace, I try to run that so it looks like I already have the exception configured because it allowed it. Let's check. Yeah, so I already have this exception configured, which is why, it did allow that to run in the test namespace, right? So if I try, of course, any other namespace, it should not allow it, right? And even if I go back to the test namespace and if I try some other image name, it should block this because the exception is specific to saying only Nginx in the test namespace should be allowed at this point. So just kind of demonstrating the flexibility and the power of Kyverno, where you can have again several different ways as you're migrating from PSPs to be able to not only manage these policies to the policy sets that we define and manage in the community, but then easily kind of allow certain exceptions to workloads which might need more time to get secured or to be compliant. And then as these exceptions, by the way, there's a separate blog post or kind of description on how you can even have time-bound exceptions with Kyverno, which kind of leads you to a lot of powerful capabilities. You can even sign exceptions for approval. So again, and any other validation policy that you want to apply can be used to also apply to exception resources, because ultimately they're just custom resources in Kubernetes itself. So that's just a quick demonstration of yet another sort of alternative and kind of choice that you have in your toolbox as you're migrating from PSPs, leveraging Kyverno in a flexible manner to start applying the pod security standards, as well as custom policies you might want to craft or using the upstream Kyverno library. So with that, I'll hand back to Chip if you want to summarize, or if there's any other things we want to cover. I think we have a few minutes left.
Yeah, I see what's a good summary here. I think the first thing is, everybody needs some security in their cluster, and the pod security is the best place to start. So if you're using PSPs today, and that's the whole topic of this, you are probably, but even if you're not, you need to handle pod security. So find some option that gives you that. If you end up not liking Kyverno for some reason, of course, we'd really like to hear your feedback and know why, but you need to handle pod security. And also, you need to keep in mind the thing with which you're going to handle it needs to meet you where you are today. So exceptions are part of life. What we typically see, and not just in Kyverno, but we have a lot of, we participate in the Kubernetes community. Almost everybody has some form of exception. Like, you can very rarely just turn something on wholesale and say, no, everything has to pertain to that standard and there's nothing that you can do. Like, you need to operate your clusters in a real world scenario that typically involves some level of flexibility. If you can get that level of flexibility in your existing tools, that's great. But the choice very often comes down to, all right, I'm either going to sacrifice security to use one tool, or I'm going to look for multiple tools that give me the flexibility I need and the security that I need. Find out what works best for you. We think that Kyverno can probably be the best option for replacing PSPs, but you should evaluate all the choices for you and then come and let us know if there's something that either is missing in the process of you looking into replacement options or something that would help to improve that experience. We're very interested in feedback on how this can be improved. And also, by the way, I'll just mention there are already some policies. Jim showed it briefly, but the Kyverno policy library has, I think, around 275 policies in it. That's more than just the pod security standards. It's very likely that whatever that you need covered that's even outside of the scope of PSPs has already been done for you. And at the very least, all you have to do is gently modify it. So go take a look at those. And also, by the way, there are some policies that are specifically for PSP migration. So the capabilities that PSP has, we've even built some policies specifically for those. If there are any that are missing, we'd like to hear about that. But check out the available options. Hopefully, for those that are either watching on the recording or may have seen some screenshots, that comparison table can help with just an at-a-glance view. We'll be adding some more of that information into the docs to help you choose the best option for you. And always make sure that you try this stuff in a test environment or a dev environment before you go to production. That's kind of a no-brainer type thing, but test these out, see what works for you, but make sure that you do it in a non-disruptive fashion, because all stakeholders need to be on the same table. You don't want to slam the door shut and implement some new technology. Only a few people know about it, and they're good, and everybody else gets caught by it. Check it out in a small environment, kick the tires, make sure that it works for you, run through the scenarios that you have in your production environment, and then you'll know for sure what the best option is going to be for your replacements as you move forward. And with that, we're basically out of time. So if there are no other questions or there are no other inputs, thanks for attending, and we'll catch you next time. And I'm not sure what we have in store for next office hours. By the way, let me just talk quickly about the 1.10 release. So Kyverno 1.10 is just around the corner. We released the first beta today, so beta 1 today. The change list is pretty large over alpha, so we're getting close to a GA release. So maybe next time we'll show some of the things that we haven't shown in prior discussions around 1.10. I don't know, but stay tuned for the next office hour that we'll do. And if you have any suggestions on what you'd like to see, hit us up, and we'd love to see what those ideas are. And with that, we'll see everybody next month.